December 7, 1941, Tokyo Arsenal, Japan. As sleet pelted against the windows of the research facility, Lieutenant Colonel Kenzo Ikeda stared confidently at the blueprints sprawled across his desk, convinced that Japanese small arms design had reached its pinnacle of excellence. The Imperial Japanese Army's Type 99 light machine gun represented what he believed to be the perfect balance of firepower, reliability, and manufacturing efficiency. In a matter of months, he would discover how catastrophically wrong this assessment would prove to be. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the story of how a single captured American weapon would transform not just one engineer's understanding of industrial design, but reveal a fundamental difference in manufacturing philosophy that would have profound implications for the course of the Pacific conflict. The news arrived on a particularly cold morning in February 1942. Captain Toshiro Yamamoto entered Ikeda's office with uncharacteristic excitement, his normally composed demeanor replaced with barely contained anticipation. A naval transport had delivered something special from the recent operations in the Philippines, an intact American Browning machine gun, the legendary M1919A4. "Colonel, you must see this immediately," Yamamoto urged, his breath visible in the unheated office. "The Americans left several of these behind during their retreat from Bataan. Our forward units managed to capture one completely intact, with nearly 1,000 rounds of ammunition." Ikeda nodded, trying to mask his own interest. The Americans were known for their industrial might, but Japanese military leadership generally considered Western weapons to be over-engineered and wasteful. The Japanese doctrine emphasized lighter, simpler weapons that could be mass-produced quickly, even if it meant sacrificing some durability. "Have it brought to the testing facility," Ikeda ordered. "Assemble our best technicians. I want to see what the Americans consider worthy of their manufacturing capacity." 3 days later, in the arsenal's main testing bay, Ikeda stood with his arms crossed as Technical Sergeant Hiroshi Nakamura and a team of 6 engineering specialists carefully unpacked the wooden crate containing the American weapon. The room fell silent as Nakamura lifted the machine gun from its packaging. 30 pounds at least," Nakamura commented, struggling slightly with the weight. "Much heavier than our Type 99. Chief Engineer Tadashi Sato approached with a clipboard. "That is already one disadvantage. Our troops can carry the Type 99 for much greater distances without fatigue." Ikeda nodded in agreement but remained silent, studying the American weapon. Even to his critical eye, the craftsmanship was immediately apparent. The metal surfaces gleamed with a deep, even bluing. There were no visible tool marks or rough edges. "Set it up for initial inspection," Ikeda ordered. "I want a complete tear-down analysis." The team worked methodically. Nakamura, who had trained at the Tokyo Imperial University before being drafted into military service, led the disassembly. His hands moved with practiced precision as he separated the major components: barrel, receiver, bolt assembly, recoil mechanism. "Sir," Nakamura called after 30 minutes of work, "you should examine this." Ikeda approached the workbench where the American machine gun now lay disassembled. Nakamura pointed to the internal components. "The tolerances," Nakamura said quietly. "They're unlike anything I've ever seen." Ikeda leaned closer. The internal parts fitted together with almost imperceptible gaps. He picked up the bolt carrier and studied it under the bright overhead lights. "How precise are these measurements?" Ikeda asked. Sato consulted his micrometer readings. "Each component is machined to within 0.002 of a millimeter. Colonel, consistently across every part we've measured so far." Ikeda's brow furrowed. "That's impossible in mass production. The Americans must be hand-finishing these weapons." Sato shook his head. "With respect, sir, there are no signs of hand-finishing. No file marks, no fitting adjustments. These parts appear to have come directly from machinery with this level of precision." The implication hung in the air. If Sato was correct, it meant the Americans possessed manufacturing capabilities far beyond what Japanese intelligence had reported. "Continue the analysis," Ikeda ordered. "I want to know everything about this weapon by the end of the week." The examination continued for 3 days. The team worked in shifts, measuring, documenting, and testing each component. On the fourth day, they reassembled the weapon and prepared for live fire testing. The arsenal's outdoor range was situated against a hillside, allowing for safe testing of automatic weapons. Despite the February cold, a small crowd of officers and engineers had gathered to witness the demonstration. Ikeda stood slightly apart, his breath forming clouds in the frigid air. Nakamura lay behind the Browning, now mounted on its tripod and loaded with American .30 caliber ammunition. At Ikeda's nod, he began to fire in controlled bursts. The distinctive sound echoed across the range, a steady, mechanical rhythm, unlike the sharper report of Japanese machine guns. After 200 rounds, Nakamura paused, allowing the barrel to cool slightly. There had been no malfunctions. "Continue," Ikeda ordered. By 500 rounds, the crowd had grown restless, but the Browning continued to function flawlessly. At 700 rounds, the barrel glowed with heat, but the action still cycled smoothly, ejecting spent casings in a neat pile. When the 1000th round had been fired without a single jam or misfire, Ikeda raised his hand to halt the demonstration. The message was clear to everyone present. This was no ordinary weapon. Back in the laboratory, with the Browning once again disassembled, Ikeda called his team together. "Explain this to me," he demanded. "Our Type 99 requires cleaning after approximately 200 rounds to prevent stoppages. This American weapon fired 5 times that number without issue. Why?" Chief Engineer Sato stepped forward. "Sir, it's a combination of factors. First, the tolerances we discussed earlier. The precision fit of components reduces wear and prevents carbon buildup from affecting operation. Second, the metallurgy is superior. Our analysis shows the Americans are using steel alloys with higher chromium content than our own. But most importantly," Nakamura interjected, "it's the design philosophy. This weapon was designed with mass production and field reliability as the primary considerations. Look at the feed system, for example." Nakamura pointed to the disassembled belt feeding mechanism. "The tolerances are tight where necessary for function, but deliberately loose in less critical areas. They've engineered significant margins for error, for dust, for heat expansion, for imperfect ammunition. This weapon was designed to keep functioning even under adverse conditions." Ikeda frowned. "Are you suggesting our designs are inferior, Sergeant?" "Not inferior, Colonel. Different in philosophy," Nakamura replied carefully. "Our weapons reflect our manufacturing capabilities and our tactical requirements for lighter equipment. But this Browning reflects something else: the ability to maintain overwhelming firepower under extended combat conditions." The room fell silent as the implications settled over the gathered specialists. Finally, Ikeda spoke. "I want a complete report. Every measurement, every material analysis, every design observation. And I want recommendations for how we might incorporate these principles into our own weapons." The next morning, Ikeda arrived at his office to find an unexpected visitor waiting: Major General Takahashi from Imperial Headquarters. The general's presence at the arsenal was unusual and immediately concerning. "Colonel Ikeda," Takahashi said without preamble, "I understand you've been analyzing captured American equipment." Ikeda bowed slightly. "Yes, General, a Browning machine gun from the Philippines. The analysis has yielded some valuable insights." "I'd like to see these insights for myself," Takahashi said. "And the weapon." Ikeda led the general to the laboratory, where the Browning lay disassembled on the workbenches. Nakamura and Sato stood at attention as they entered. "Explain your findings," Ikeda instructed them. For the next hour, the technicians detailed their analysis. They showed the general microscopic examinations of the metal compositions, precision measurements of the components, and diagrams comparing the American design to Japanese counterparts. When they finished, General Takahashi remained silent for a long moment, his expression unreadable. "You realize the implications of what you're suggesting," he finally said. "If this level of precision is standard in American manufacturing, their industrial capacity is far beyond our intelligence estimates." "That is our conclusion, General," Sato confirmed. Takahashi turned to Ikeda. "How widely has this information been shared?" "Only within this team, sir. We were preparing a formal report for headquarters." "That report will be classified at the highest level." Takahashi said firmly. The Emperor's ministers must see this, but it cannot become common knowledge. It would be demoralizing. Ikeda understood the subtext. Japan had entered the conflict believing in its technological and spiritual superiority. Evidence suggesting otherwise could undermine military morale and civilian support for the war effort. There is another matter, Takahashi continued. Imperial Headquarters has approved a project to reverse engineer certain aspects of Western equipment. Your team will lead this effort, focusing on incorporating these manufacturing techniques into our existing designs without requiring complete retooling of our factories. Ikeda bowed. We are honored, General, but such a task presents significant challenges given our current industrial capabilities. I'm aware, Takahashi replied sharply, but necessity dictates we must try. The future of our nation's defense may depend on it. After the general departed, Ikeda gathered his team. We have new orders, he announced. We are to adapt what we've learned to improve our own weapons within the limitations of our manufacturing capacity. Nakamura raised a hand. Colonel, with respect, that may be impossible. Our entire industrial system would need restructuring to achieve American-level precision. I'm aware, Sergeant, Ikeda replied, but we must try. Begin with the feed system of the Type 99. If we can improve reliability even marginally, it could make a significant difference in the field. The next months brought long hours and frustration. The team worked to redesign components of Japanese machine guns, incorporating principles observed in the American Browning. But each attempt revealed the same fundamental issue. Japan's manufacturing base simply could not match American precision at scale. In June 1942, disturbing reports began arriving from Midway. The Imperial Japanese Navy had suffered a devastating defeat. Among the confidential assessments crossing Ikeda's desk was an analysis suggesting that superior American aircraft maintenance had played a crucial role. Their planes could fly more sorties with fewer mechanical failures. The parallels to what his team had discovered were unmistakable. It wasn't just weaponry. American mechanical reliability extended across their entire war machine. One evening, as Ikeda worked late in his office, Captain Yamamoto entered with a folder bearing high-security classifications. Field reports, Colonel, Yamamoto said quietly. From Guadalcanal. Ikeda read them with growing concern. Japanese forces were reporting frequent weapon jams in jungle conditions. American forces, with their Brownings and other automatic weapons, were maintaining superior firepower during extended engagements. The reports confirmed what the Arsenal team had predicted months earlier. The technical advantage was translating directly to tactical advantage on the battlefield. In August, an unexpected opportunity arose. A captured American ordnance officer, Captain William Miller, was being transported to mainland Japan for interrogation. Ikeda requested permission to question the officer about manufacturing techniques, promising to share any intelligence gained with Imperial Headquarters. The meeting took place in a small room at the Arsenal, with only Ikeda, Nakamura as translator, and 2 Kempitai officers present. Captain Miller, despite his circumstances, maintained a professional demeanor. Captain, Ikeda began, with Nakamura translating, I wish to discuss American manufacturing methods, particularly for automatic weapons. Miller raised an eyebrow. That's an unusual line of questioning, Colonel. Nevertheless, it is what I wish to discuss. Miller considered for a moment before responding. I'm an ordnance officer, not an engineer, but I can tell you what I know. What followed was a revelation. Miller described American factories where parts moved from one specialized machine to another on assembly lines. Each operation performed with precise tolerances. He spoke of interchangeable parts produced not by skilled craftsmen, but by machine operators following standardized procedures. The genius isn't in the individual worker, Miller explained. It's in the system. Our factories are designed so that relatively unskilled labor can produce incredibly precise results through properly designed machinery and rigorous quality control. When Ikeda asked about the Browning specifically, Miller smiled slightly. The 1919 A4 is practically a national institution. John Browning designed that action in 1917. We've been refining the manufacturing process ever since. Every major arms maker in America can produce parts for it, and they'll all fit together perfectly. That's not craftsmanship in the traditional sense, it's industrial standardization taken to its logical conclusion. After Miller was taken back to the detention facility, Ikeda sat alone in his office, contemplating the conversation. The American had confirmed what the technical analysis had suggested. The difference wasn't just in design or materials, but in the entire approach to industrial production. That evening, Ikeda drafted a confidential memo to General Takahashi, outlining what he had learned and its strategic implications. He concluded with the assessment that he knew might end his career. Based on our analysis of American equipment and manufacturing capabilities, I must report that Japan cannot match United States production quality or quantity with our current industrial system. The gap is not one that can be closed within the time frame of the current conflict. Strategic planning should account for this reality. 3 days later, Ikeda was summoned to Imperial headquarters in Tokyo. He expected to be relieved of his position, possibly even court-martialed for defeatism. Instead, he found himself in a meeting with senior members of the Army Technical Bureau and the Ministry of Munitions. "Your report has caused quite a stir, Colonel," said Lieutenant General Yoshijiro Umezu, Chief of the Army General Staff. "Some considered it defeatist, others found it treasonous." Ikeda remained at attention, awaiting what seemed an inevitable judgment. "However," Umezu continued, "we have corroborating intelligence from other sources. Our naval attachés in Germany have reported similar observations about American manufacturing. And our own field reports indicate mechanical reliability issues affecting our operations." Another officer, whom Ikeda did not recognize, spoke up. "The question before us is not whether Colonel Ikeda's assessment is accurate, but what can be done about it, given our current resources." The discussion that followed was unlike any Ikeda had experienced in his military career. For perhaps the first time, senior leadership was openly acknowledging a fundamental disadvantage in Japan's war-making capacity. Various proposals were suggested, focusing on quality over quantity, prioritizing certain key weapons systems, even reaching out to German engineers for manufacturing expertise. At the end of the meeting, General Umezu addressed Ikeda directly. "You will continue your work at the arsenal, Colonel. Focus on practical improvements that can be implemented immediately with our existing capabilities. Longer-term industrial reform is beyond your scope." The message was clear. The strategic situation would not be shared with the broader military or the public. Japan would continue the fight with the resources it had, making whatever incremental improvements were possible. Back at the arsenal, Ikeda gathered his team and gave them their new directive. "We will focus on reliability enhancements for existing weapons," he explained. "No major redesigns, no changes requiring new machinery or extensive retraining. Work within the system we have." For the remainder of 1942 and into 1943, the team labored on modest improvements. They adjusted tolerances where possible, modified maintenance procedures, and developed field repair techniques. These changes helped, but as the war situation deteriorated, their efforts increasingly resembled emergency measures rather than systematic improvements. In April 1943, as American forces advanced across the Pacific, Ikeda received orders to begin preparing technical documentation for emergency production facilities in mainland Japan. The implication was clear. The empire was preparing for a defense of the home islands. During this period, Nakamura approached Ikeda with a personal concern. "Colonel," he said hesitantly, "I've been thinking about what we learned from the American machine gun. The principles apply beyond military equipment." "Explain," Ikeda prompted. "The standardization, the precision manufacturing, the systems approach to production, these are not just techniques for making weapons. They represent a fundamental approach to industrial organization that could be applied to everything from automobiles to household appliances." Nakamura paused, choosing his next words carefully. "Regardless of how this conflict ends, Japan will need to adopt these methods if it wishes to become a modern industrial power." Ikeda studied the young sergeant thoughtfully. "You're thinking beyond the current situation. Someone must, sir," Nakamura replied quietly. Ikeda nodded slowly. Document your thoughts, Sergeant, not for current leadership, but for whoever comes after. There may come a time when such ideas will be needed. By mid-1944, the strategic situation had grown dire. American bombers were now reaching the Japanese mainland, and reports from the front lines increasingly described desperate situations. The arsenal's focus shifted almost entirely to emergency production of simplified weapons for homeland defense. In November, as American B-29 bombers began systematic raids on Tokyo, Ikeda was ordered to disperse his technical team to various backup facilities throughout the countryside. Before they separated, he gathered them one last time in the arsenal's main laboratory. What we learned here about American industrial methods may be more important than any weapon we analyzed, he told them. Each of you now carries that knowledge. Whatever happens in this conflict, remember what you've seen. There will come a day when Japan must rebuild. When that time comes, remember the lessons of the Browning. The team dispersed the following day. Nakamura was assigned to a small production facility near Nagano, Sato to a research center in Kyoto. Ikeda himself remained in Tokyo, coordinating what remained of the arsenal's activities as the bombing intensified. In February 1945, the arsenal took a direct hit during a bombing raid. Much of the facility was destroyed, including the laboratory where the Browning had been studied. Ikeda suffered minor injuries, but continued his duties from a backup location. As the war situation grew increasingly desperate, Ikeda was tasked with evaluating various last resort weapon proposals. He reviewed them dutifully, but privately recognized their futility. The fundamental industrial gap that his team had identified years earlier had only widened as American production reached unprecedented levels. In August 1945, as Japan faced the shock of atomic attacks and Soviet entry into the Pacific War, Ikeda received his final wartime orders: destroy all sensitive technical documents before they could fall into enemy hands. As he supervised the burning of research files and technical drawings, he came across the folder containing the original analysis of the Browning machine gun. He held it for a long moment, then set it aside, placing it instead in his personal briefcase. The war ended days later. Like many military officers, Ikeda faced an uncertain future in occupied Japan. He was questioned by American technical intelligence officers about Japanese weapons development, but was not charged with any wrongdoing. Released from service in December 1945, he returned to his family home near Yokohama. For several months, he lived quietly, avoiding public attention as Japan began its painful transition to peace. Then, in April 1946, he received an unexpected letter. It was from Hiroshi Nakamura, his former technical sergeant. "Colonel," the letter read, "I am now working with a group of engineers planning for Japan's industrial reconstruction. Several of us who studied the American equipment during the war are applying those lessons to civilian manufacturing. We believe Japan can adopt these methods and eventually compete in global markets. If you are willing, we would value your experience and guidance." Ikeda read the letter several times. From his briefcase, he retrieved the folder containing the Browning analysis, the document he had saved from destruction. The next day, he traveled to Tokyo to meet with Nakamura and his colleagues. The meeting took place in a small office above a partially rebuilt factory. A dozen engineers, most of them former military technicians, gathered around a makeshift conference table. Nakamura, no longer in uniform, but still showing military precision in his movements, made the introductions. "Many of you know Colonel Ikeda," Nakamura said. "He led the arsenal team that first identified the manufacturing principles we now hope to implement." Ikeda looked around the room at the young faces, seeing in them an energy and purpose that had been missing in the war's final desperate months. "What I know about American manufacturing methods came at great cost," Ikeda told them. "But that knowledge does not belong to the past. It belongs to Japan's future." He opened the folder and spread the technical drawings across the table. The lesson of the Browning wasn't about weaponry. It was about an approach to industrial organization that values precision, standardization, and systematic quality control. These principles can be applied to anything we might build. For the next several hours, the group discussed how American manufacturing techniques could be adapted to Japan's rebuilding economy. They talked of precision machining, statistical quality control, and production systems that minimized variation. As the meeting concluded, a young engineer asked, "But how can we match American industrial capacity? They have resources we can never hope to obtain." Ikeda considered the question carefully. "We don't need to match their resources," he finally replied. "We need to exceed their precision. Where they use abundance, we will use efficiency. Where they use scale, we will use quality. Our path forward isn't to become America. It's to learn from America, then find our own way." Nakamura smiled at his former commander's words. "That is exactly what we intend to do." In the years that followed, Ikeda worked as a consultant to several emerging Japanese manufacturing companies. He never spoke publicly about his wartime analysis of American equipment, but his technical insights helped shape new approaches to quality control and precision manufacturing. By 1955, as Japan's economic recovery gained momentum, many of the principles that Ikeda and his Arsenal team had identified in the Browning machine gun had become standard practice in Japanese industry. Precision, reliability, and systematic quality control were becoming hallmarks of Japanese products. In 1960, Ikeda attended the opening of a new electronics factory near Tokyo. The facility featured automated assembly lines, rigorous testing procedures, and a quality control system that tracked defects to their source. As he toured the production floor, he was approached by an elderly man whom he didn't immediately recognize. "Colonel Ikeda," the man said with a slight bow. "You may not remember me. I was part of your technical team at the Arsenal. Tanaka, junior engineering specialist." Ikeda smiled in recognition. "Of course, Tanaka. How are you faring these days?" "Very well, sir. I'm a quality control manager here." Tanaka gestured around the factory floor. "Much of what we do here came from what we learned back then. The precision measurements, the statistical quality control. It all started with that American machine gun." Ikeda nodded thoughtfully. "What we learned then was valuable. But what you and others have built here goes far beyond that. You've created something new, a Japanese approach to manufacturing excellence." "Perhaps," Tanaka replied. "But we needed that initial insight, that moment when we took apart the American machine gun and saw why it never jammed. It changed everything." As Ikeda departed the factory that evening, he reflected on the long journey from the Arsenal's laboratory to Japan's emerging position as a manufacturing powerhouse. The war had been lost, but in that defeat, the seeds of a different kind of victory had been planted. The lessons taken from a single American machine gun, precision, standardization, systematic quality, had transcended their military origins to become founding principles of Japan's industrial rebirth. The same attention to detail that had made the Browning so reliable in battle was now being applied to cameras, radios, and automobiles that would soon be exported worldwide. It was, Ikeda thought, a profound historical irony. The weapon that had helped defeat Japan had also helped reveal the path to its future prosperity. In 1965, nearly 20 years after the analysis of the Browning machine gun, Japan's industrial output reached pre-war levels. The nation that had once struggled to match American manufacturing quality was now setting new global standards for precision and reliability. Kenzo Ikeda, by then retired and in his 70s, received an invitation to tour one of Japan's newest automotive factories. As he walked through the facility, observing the automated systems and quality control processes, he recalled the words he had spoken to his Arsenal team on their final day together. Remember the lessons of the Browning. They had remembered. And in doing so, they had transformed not just Japanese industry, but the global understanding of manufacturing excellence. The precision that had once seemed impossibly beyond reach had become the new standard. Ikeda smiled as he watched the assembly line produce car after perfect car, each one a testament to the unlikely lessons learned from an enemy's weapon. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.